Okay, this video tutorial looks at the mathematical strand of patterns and algebra, and more specifically, we're going to focus on our understanding of simplifying uh, through the product and quotient rules. So essentially, there are two steps to be able to simplify using the product, which is multiply, and the quotient, which is the divide rules. So your first step is simply just to calculate the coefficient by multiplying all the numbers. So essentially, remember the coefficient is the number in front of the variables. And then you simply simplify the unknowns using index notation. And please make sure that the unknowns are written in alphabetical order, so the variables should always be in alphabetical order. Now, I said in step one that you need to calculate the coefficient by multiplying, right? That may also include dividing if you need to divide the coefficients. Okay, so it could be multiplying or dividing. We'll go through a few examples and I'll explain what that means. Okay, so with our first couple of examples here, remember this is product simplification, so we're actually multiplying. In our first example, remember step one was to multiply the numbers first. So we end up with 2 times 3, and then we end up with a times a. So 2 times 3 is 6. A times a simply gives me a squared. In my second example, we have our numbers of minus 3 times by 4. Then we simply put our letters in. Now we've got a to the power of 2 times a times b. If we do our numbers first, we end up with negative 12. And remember, a to the power of 2 times a is actual like terms, so we can use index laws for that. That gives us a to the power of 3. And then we put our b in using algebraic notation where we don't put the multiplication sign. Okay, we're now going to do some simplification using the quotient rule or the divide rule. Right. Our first example, we have 6a to the power of 3 all over 3a. We can simplify these just by using our division or our index laws. Now, a to the power of 3 over 3a. The 6 and the 3 actually cancel out to 2 and 1. And then we can also cancel off a to the power of 3, because remember that a to the power of 3 is a times a times a. If this is all over a, we can simply cancel 1 off the bottom and 1 off the top. And what that does is that leaves us with 2a squared all over 1, okay, which actually just equals 2a squared. If we're going to do our second example question here, we have 4a b to the power of 2 all over 12 a squared and b. We can cancel off. 4 and 12 becomes 1 and 3. A over a squared is simply this. So we can cancel off an a and an a, which leaves a 1 and an a. So this becomes times 1 times a. And then b squared over b. B squared is actually b times b. All over b, we can cancel off a b and a b. So that leaves us with b over 1. Right, remember, it's all multiplication here. So this simply leaves us with b over 3a. Okay, so here are some practice questions I'd like you to have a go at simplifying using either the product or the quotient rule. Feel free to pause the video, have a go at them. When you think you've got them correct, continue the video and we'll see how you went. Okay, so let's see how you went. In our first example, we times the numbers together first. 4 times 6 is 24, and then a times a gives me a squared. Second example, negative 2 times negative 4 is positive 8. A squared times a gives me a cubed, and then I'm left with b squared. In my third example, 12 divided by 4, that can cancel to be 3 over 1. And then a over a squared cancels down to just be 1 over a. So then my answer for that would be 3 over a. Now remember, that's an a, not a 9. Now my last question, I've got 16 over 12 can cancel down to 4 over 3. A over a squared, again we just did that previously, cancels down to 1 over a. And then b squared, there's no b's down the bottom, so that stays, and there's the c down the bottom, but there's no c up the top, so that stays. So this simply just gives me 4b squared over 3ac.